Okay, welcome friends. We are knowing here Taylor's expansion. Taylor's expansion of function, and here we are knowing that this to find Taylor's expansion of this function should be continuous and differentiable. If function is continuous and differentiable, then we can find its Taylor's expansion. Now here in our usual life, every functions are not continuous and differentiable. We'll discuss here. Suppose function is not continuous and differentiable, but function is periodic. Function is periodic. Now if function is periodic, in suppose some interval is given, suppose I will take interval 0 to 2 pi, usual our interval 0 to 2 pi. This function is periodic in interval 0 to 2 pi. Then shall we express this function in some expansion or in some series? Let us will try to check. Before that, I will write here what is meaning of periodic function. Periodic function means function goes on repeating after some time. Suppose I will take here this function. This is sine wave, half range sine wave. Here 0 and so on. I will take pi, 2 pi, 3 pi and so on. Now this function goes on repeating in 0 to 2 pi. 0 to pi here, half range I am taking, 0 to pi. Now this is sine wave. In 0 to 2 pi this is continuous, but this function shows here this curve. And if I will take this range 0 to 2 pi, we are getting curve in this way. And here discontinuity is there. Again we are getting this part of curve, discontinuity is there, this part of curve, discontinuity is there. I mean this function is a periodic in interval 0 to 2 pi. After 0 to 2 pi, this function goes on repeating. Therefore, here I will define this function in this way. Function f of x is equal to f of x plus t. I will suppose this is a t is a period of this function. If this function satisfying this condition, then t is a period of this function. And t is called period of this function. Every periodic function repeating after some this time t. This function goes on repeating, therefore this is a periodic function. Now I will consider this my function is a periodic in interval 0 to 2 pi. That means here 0 is less than x is less than equal to 2 pi. My function is defined in this way. This function is periodic. Let us I will try to express this function in this way. And then what will happen? F of x is equal to a0 by 2 plus a1 into cos x plus a2 into cos 2x plus a3 into cos 3x plus so on terms, means all terms containing cosine angle, plus b1 into sin x plus b2 into sin of 2x plus bt into sin of 3x plus so on terms. Means here just like in Taylor's expansion, we are expressing our function in powers of x minus x0. Here this function is periodic and I am trying to express this function in combination of sine and cosine function. This is a1 into cos x, a2 into cos 2x, a3 into cos 3x and so on. b1 into sin x, b2 into sin 2x, b3 into sin 3x and so on. That means here a1, a2, a3 these are the coefficient of cosine term, b1, b2, b3 these are the coefficient of sine term. I will write this in symbolically. I will write here this expression as summation. This is a1 into cos 1, a2 into cos 2 angle is here. Therefore I will write here an into cos of nx plus bn into sin of nx, and n varying from 1 to infinity. Means here I will express this my function in combination of sine and cosine term. In this function is periodic and I can express this function in combination of sine and cosine function. Here this expression is called Fourier series, and a0, an and bn are the Fourier coefficients. And these are the Fourier coefficients, and this series is called Fourier series. Now means my function is periodic, satisfying some conditions also, and we can write this function in this way, combination of cosine and sine function, and this is called period. This is called Fourier expansion or Fourier series, and a0, an and bn are the Fourier coefficient. For this expression, suppose I will say this is my equation number 1, this is my Fourier series 1. For this equation 1, if I will integrate between 0 to 2 pi, if I will integrate between 0 to 2 pi, then what will happen? This integration 0 to 2 pi of cos nx and integration 0 to 2 pi of sin nx get cancelled. That means we are getting integration as 0. Only this a0 term is there, and then we will get your first coefficient. When we are integrating 0 to 2 pi, we will get first coefficient as a0 is equal to 1 divided by pi integration 0 to 2 pi this f of x into dx. This is your first Fourier coefficient. Again, if we are integrating this function, this equation 1, before that integrating equation 1, if I will multiply this equation of by cos of nx and integrating between 0 to 2 pi, then this term becomes 0, this will term become 0, and only we will get this function as n is equal to 1 divided by pi integration 0 to 2 pi f of x into cos of nx into dx. This is your second Fourier coefficient. In similar way, if we are integrating, if we are first of all multiplying equation 1 by sin nx, this equation 1, if we are multiplying by sin nx and integrating between 0 to 2 pi, we will get this coefficient bn as integrate 1 upon pi 0 to 2 pi f of x into sin of nx into dx. These are the Fourier coefficient. Means here we will get periodic function. We can write in this form. This is called Fourier series or Fourier expansion. a0 divided by 2 summation n equal to 1 to infinity n into cos of nx plus n is equal to 1 to infinity bn into sin of nx, where a0 is equal to, these are the Fourier coefficient, a0 equal to 1 upon pi 0 to 2 pi f of x into dx, n equal to 1 upon pi 0 to 2 pi f of x into cos of nx into dx, and bn is equal to 1 upon pi 0 to 2 pi f of x into sin nx into dx. Means this is our periodic function with period 2 pi, 0 to 2 pi. This is our period. In this period we can write our Fourier series expansion. Now here in general way I will talk here my function f of x is defined in interval c to c plus 2l with period 2l, then its Fourier expansion or Fourier series is f of x is equal to a0 divided by 2 plus summation an into cos of n pi x divided by l plus summation bn into sin of n pi x divided by L, n equal to 1 to infinity, n equal to 1 to infinity. Here in last case period was 0, period was 2 pi. Instead of 2 pi I am taking here 2n. Then we can write Fourier expansion in this way: a0 divided by 2 plus n is equal to 1 to infinity a n into cos of n pi x divided by L plus summation n equal to 1 to infinity bn into sine of n pi x divided by L. This is our Fourier series expansion in general interval c to c plus 2l, in any interval c to c plus 2l with period 2l. Period is 2l, therefore I can write here Fourier expansion in this way. This is my Fourier expansion in general case. Now here where Fourier coefficients are a0 is equal to, in last case there was 1 upon pi, here instead of pi 2l is here and half range is L. 1 upon L integration c to c plus 2l f of x into dx. Bn equal to 1 upon L integration c to c plus 2l f of x into cos of n pi x divided by L into dx. And sorry, this is an, and Bn equal to 1 upon L integration c to c plus 2l f of x into sine of n pi x divided by L into dx. Now this is the general formula. Using this general formula you can find Fourier expansion of any function with satisfying some conditions. Again we will not find here Fourier function of every function which is only periodic function. Again some conditions are also there. I will discuss these conditions. Before that, here we'll write here Fourier expansion for this function f of x defined in this interval with period 2l. With period 2l, then its Fourier series expansion is f of x equal to a0 divided by 2 plus summation n equal to 1 to infinity a n into cos of, this angle is important, n pi x divided by L. And how we are finding L? Because here from this interval we will get 2l and we are dividing by L only. Here again plus Bn into sine of n pi x divided by L. This is our Fourier series expansion, and to find out this Fourier series expansion we need a0. How we are finding a0? 1 divided by L c to c plus 2l f of x into dx. An is equal to 1 upon L c to c plus 2l f of x into cos of n pi x divided by L into dx, and Bn equal to 1 divided by L c to c plus 2l f of x into dx. These are the Fourier coefficients, and we can find Fourier coefficient in this way. If we are finding these Fourier coefficient and putting in this equation star, if we are putting in this equation star, then we will get Fourier series expansion of that function. We'll go towards one example. We'll find here example. We have to find Fourier series expansion of f of x is equal to x in interval 0 to 2 pi. A function is defined in interval 0 to 2 pi. Here interval is given 0 to 2 pi. Therefore, I will say that this period is 2 pi. This is 2 pi minus 0. We will find here period is 2 pi with period 2 pi. 2 pi. If we will compare this problem to last general method, our general method is c to c plus 2l. Here if I will compare this and this, here c equal to 0 and 2l is equal to 2 pi, therefore we will get L is equal to pi. Only I will compare here because we have to write our formula in general range c to c plus 2l. C to c plus 2l in general range we will discuss, mean this is more global than any range. Now here using this we can find this is our 2l, means we are getting 2l because in our formula we need L 2l is equal to 2 pi, therefore L equal to pi. Now I will write here first of all formula for Fourier expansion. What is formula? Fourier expansion or Fourier series. F of x is equal to a0 divided by 2 plus summation n into cos of n pi x divided by L plus summation bn into sine of n pi x divided by L. N equal to 1 to infinity, here n equal to 1 to infinity. This is our equation number star. But before the star, I will write here again. I will put value of L because range is here 0 to 2 pi. We are writing this formula for this range C to C plus 2L, and here I will put value of L. L is equal to pi. Now I will put again here value of this pi a0 by 2 plus summation n into cos of n pi x divided by L. Value of L is pi, and pi get cancelled because L is pi. This is nx plus summation f of x into sine of nx, because we are putting here L equal to pi. If we are putting L equal to pi, L equal to pi get cancelled, here pi get cancelled, and now I will write this is equation number star. This is my equation number star. Now our aim is to find out this a0, an, and here is bn and bn. We'll find out these Fourier coefficient. Now henceforth, if I am not writing here summation, but you should assume that this is from n equal to 1 to infinity. Now we will find here this Fourier coefficient. This is our f of x. Now again I will write here formula where a0 is equal to 1 upon L integration c to c plus 2L f of x into dx. I am taking every time general formula. And what is our range? Instead of c to c plus 2L, our range is 0 to 2 pi. C to c plus 2L, I will compare these two ranges, 0 to 2 pi. I will write here this as 1 divided by L. L is now pi. 0 to 2 pi. F of x. What is our f of x? In our problem, f of x is x. I will put here x into dx. What is integration? 1 upon pi. Integration is x square divided by 2. Integration of x is x square divided by 2 between limit 0 to 2 pi. And here we are getting this is 1 upon pi. Upper limit is 2 pi. Therefore 2 pi square is 4 pi square divided by 2 minus lower limit is 0. This is 2 pi square only, and one get here cancel pi. Therefore we are getting this as 2 pi only. Means your a0 equal to, I will write here, a0 is equal to 2 pi. This is our a0. a0 equal to 2 pi. Hence we are getting first a0. Now we will find an. What is an? An is equal to 1 divided by L integration c to c plus 2L f of x into cos of n pi x divided by L into dx, because we are knowing this formula. I will put all these values here. 1 divided by pi. Our range is now as per given problem 0 to 2 pi. What is f of x? Is x into cos of. Now I will put pi. L is equal to pi. Pi get cancelled. This is only an x into dx. Now we have to solve this integration. Again, we studied this one rule. If this is polynomial function, then how to find this integration? We have to use here Leibniz rule to find out integration in this case. To find out integration, we have to keep this x as it is. Integration of this function sine of nx divided by n integration minus derivative of this function is 1 into integration of this function is cos of nx again divided by n. This becomes n square. Then after this derivative is 0, therefore we have to stop here. and limits are 0 to 2 pi. 0 to 2 pi. Then I will put here upper limit and lower limit. I will put upper limit. Upper limit is 2 pi. This is 2 pi into sine of, I am putting x is equal to 2 pi, then total becomes 2n pi whole divided by n, minus plus cos of 2n pi, because x is 2 pi divided by n square. This is your upper limit, minus lower limit. X is 0, therefore this total term becomes 0. Now minus plus cos 0. What is cos 0? Again I will put here cos 0. Cos 0 is 1. This is equal to 1 divided by pi. This is 2 pi, but we are knowing that sine of 2n pi. Sine of 2n pi is 0. Therefore this total term becomes 0. Plus cos of 2n pi. Cos of 2n pi, again we are knowing that this is n to n pi. Cos of 2n pi is 1. This is 1 divided by n square, minus cos 1 is 0. We are getting this is equal to 0. Cos minus cos 0 is 1. 1 divided by n square. And this total becomes 0. This is 1 by n square and minus 1 by n square get cancelled, and we are getting this is equal to 0. Means here we are getting an equal to 0. This is for all n. An equal to 0 for all n. Now we will find out our bn. Now this bn equal to, what is formula for bn? 1 divided by L integration 0 to c plus 2L f of x into sine of n by x divided by L into dx. Again, as per given problem, our L is pi and our range is 0 to 2 pi. 1 upon pi 0 to 2 pi f of x is x into sine of nx into dx. Again, this is your polynomial function. I will use our formula to find out integration. This is x into integration of this function is minus cos of nx divided by n, minus we have to find out derivative of this function, into integration of this function minus sine of nx divided by n square. Now after this derivative becomes 0, therefore we have to stop here. This is equal to 1 upon pi. I will put here limit 0 to 2 pi. Now I will put upper limit and lower limit. Now I will directly put here limit. This is 2 pi into minus cos of 2n pi. This minus sign I will take here, divided by n. Minus, this is upper limit. Minus plus. We are getting here sine of 2n pi divided by n square. This is our upper limit. Minus lower limit. This is 0. Therefore, this total term becomes 0. We have to put x equal to 0. Total term becomes 0. Minus. This is sine 0. Sine 0 is again 0. 0 plus 0 we are getting here. This is nothing but 1 upon pi. Cos of 2n pi. Cos of 2n pi is 1. This is minus 2 pi divided by n. Plus sine of 2n pi is 0. And here this pi get cancelled. We are getting this term as 1 by pi into minus 2 pi divided by n. Pi get cancelled. We are getting here minus 2n. Means value of this is, we are calculating bn. This bn equal to minus 2 divided by n. This whole for all n. Means we have calculated all. A0. This is our problem. We have to solve this problem. For that we have taken Fourier series. This is our Fourier series. We have to calculate A0, and A0 is our 2 pi. And we have to calculate an. We have calculated an and we are getting an equal to 0. Then we have to find out bn, and bn is equal to 2n pi. Therefore, putting all this value in star, this is our star, this is our star. Therefore, equation star becomes f of x is equal to a0 divided by 2. And what is a0? For a0 is, we have calculated 2 pi. This is 2 pi divided by 2 plus summation an. All an becomes 0. An into cos of nx, and all an becomes 0. Therefore, total term becomes 0 plus summation bn. What about bn? Bn is here minus 2 divided by n. This is minus 2 divided by n into sine of nx. I will rewrite this as pi plus this total term is 0 because all an's are 0. Summation minus 2 divided by n into sine of nx, or this is equal to pi minus 2 into summation sine of nx whole divided by n is equal to 1 to infinity. This is our function f of x, but f of x is x. This is our series expansion of function f of x in interval 0 to 2 pi, and this is called Fourier series expansion of our function f of x. Okay, thank you.